Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session, we have completed the system of particles, the motion of system of particles and center of mass. So we discussed in detail about the center of mass concept, so then collisions concept, and collisions in 2D, elastic, inelastic collisions, all these concepts were covered in the previous sessions, right? So now we are going to start the last chapter of your mechanics, and most of the students feel so this is a difficult chapter in whole physics of class 11th and class 12th. Okay, so yes, indeed it's a difficult topic only, but for whatever the JEE mains and NEET, so some concepts will be there in the rotational motion which will be repeated, or so the questions will be framed on such topics only. Okay, so what we do is from today onwards I'll take some 10 lectures for the rotational motion. So step by step we'll learn. So everything, from basics to advanced level, so we'll learn step by step. Okay guys, so I just need your attention during the classes. So once you have started the lecture, just finish it off in one stretch. So don't go for 2 or 3 times, like what I mean to say is, so just if you watch the lecture for 20 minutes, so then again take the break and again, so next 20 minutes, so that will not work. So for the next 1 hour, just be with me, complete the lecture in one stretch, and at the end of the lecture write all the formulae and shortcuts, tricks, whatever we discussed in the class, so as a short notes. Okay, so and before going to the next lecture, so what you do is revise the previous lectures and go to the next lecture. Okay, so that's a very good practice to learn the formulas and to remember the formulas. Okay, chalo. So let's start the today's topic. So the rotational motion, lecture number 1. So total 10 lectures I am going to take for this chapter, and I am going to solve n number of questions. Don't worry, I'll take previous year questions as well, and I'll take some questions which can be asked. There is a probability to ask some questions, so I'll take such questions or such models also. So I'll solve it here. Okay, so you also take some questions once the class completed. So based on the topic, so you have n number of resources to solve the questions. We have PW library in our PW app, so you can solve it from there, or if you have any other material you can solve it from there, or we have PW modules, books, if you have bought offline books from the PW store, so you can practice from there. Your wish, practice from anywhere, but you have to practice, that's it. Okay, chal. So our today's goals are, first we'll discuss about the angular variables, introduction to angular variables. So then we'll talk about so the torque or moment of force, then so the torque, net torque concept we'll discuss, and some numericals we'll do. Okay, chal. So this class is going to be just brushing up your previous topic, especially the circular motion will have the relation with the rotational motion. So whatever we learned in the circular motion, we are going to brush up those basics first. So then we'll go for the rotational motion concept, that is torque will be introduced in today's session. Chalo guys, so first, so the rotational motion, see here, a rigid body is said to be pure rotation. See, the rotational motion is only for the rigid body. The rotational motion is for the rigid bodies. That's why it's also called rigid body dynamics. So in some books or some modules they write rigid body dynamics. So what is rigid body dynamics? The rotational motion only. So the rotational motion is for the rigid body. So what is the rigid bodies are then? Rigid body is a body in which so the distance between 2 points will not change. Let's suppose if it is a body, so there is one point here and there is one more point here. So the distance between these 2 points will never change. So such body is said to be the rigid body. Okay. So now what is the rotational motion, sir? See here, I am taking some irregular rigid body here. So this is a body, and then it is pivoted here. It is pivoted at point A. So now what I am doing is, so I am moving it to this side. So to make some angle theta, so we are moving this one to this side. Okay, so then if you observe in this process, So let's suppose I am considering a particle of, this is a point on the rigid body, so which has moved to some B to B dash, and I am considering one more point, let it be some P point. So it moved to some other P dash point after the complete rigid body has moved. So the particles of it are also moving, yes or no? So here I am considering some Q point, so it has moved to Q dash point. So let's suppose if I take R point, so it will move to some R dash point. So now if you observe, all the points of the rigid body are making the circular motion. All the points of the rigid body, so they are making the circular motion. Once we rotate this one about a pivoted point, so what happened, these points are moving, so right, so they are making the circular path. And so, and one more thing, so they all have the common center for this circle. If you complete this circle, so the center for this one is this one, and if you complete the circle this one, so then the same center, and then if you complete the circle this one, so and again same center, so they have the common center. So such motion is said to be the rotational motion. Okay, see here, a rigid body is said to be pure rotation if every particle of the body moves in a circle. See here, every particle of the body moves in a circle. So and the centers of all circles lies on a straight line. So centers of all circles, they are lie on a straight line, yes or no? So called the axis of rotation. What is that? That's the axis of rotation. About this is the axis of rotation. See here, for this particular point, so wherever it is pivoted, so that pivoted point is acting as a center, right? So about this point they are rotating, about this point they are making the circular motion. So then this is the axis of rotation, this is the axis of rotation about which this body is said to be rotating. Clear? Understood, guys? So what is the rotational motion? The rotational motion is for the rigid bodies. That's why it's also called the rigid body dynamics. We also call it as the rigid body dynamics. Clear? Sure. So let's move further. Hope you understood now. So now, so we already know the angular terms. So what are the angular terms? The theta is the angular displacement, omega is the angular velocity, and the angular acceleration is alpha, right? We have already studied about this. So where theta is a angular displacement, so which is measured in radians, We already know what is the relation between radians and degrees. So the pi stands for 180 degrees, right? So pi by 2 stands for 90 degrees, and pi by 3 stands for 60 degrees, and then pi by 4 stands for 45 degrees, right? So these are the radians, so degrees to radians, and theta is a axial vector, right? So the theta is a angular displacement which is a axial vector, which will be along the axis of rotation, axial vector. We have already studied about it. So then next we have the angular velocity. So what is the angular velocity? Omega. So the angular velocity, two types of angular velocities are there. Omega average, which is, so we can write theta 2 minus theta 1 by T2 minus T1, right? So which is nothing but delta theta by delta T, or so the instantaneous acceleration, instantaneous angular velocity, so which is d theta by dt, d theta by dt. So this omega is also axial vector. It will be along the axis, axial vector. How do you find the direction of this axial vector, theta or omega? So let's suppose if the body is moving in a circular path like this, so then if you curl your fingers in the direction of the circular path of the body, so then the thumb gives the, sorry guys, the thumb gives the direction of angular displacement and angular velocity. Angular displacement and angular velocity, they both will be in the same direction. So if the circular path is like this, so they both will be in this direction. If the body is moving right side, this side, so then the angular velocity and angular displacement will be inside, inwards. Clear guys? Understood? Sure. So this is about the omega. So what are the units of omega? So just I am recapping the previous terminology that what we learned. So this is done. So the units are radians per second, and then we also studied, so what is the relation between the theta and omega. So from here omega is equals to d theta by dt. So from here d theta is equals to omega dt from here. So let's integrate it on either side. So the integration of d theta is equals to integration of omega dt. So theta is equals to the integration of omega dt. So that means the area under angular velocity and time curve will result in the angular displacement. Yes or no? So the area under, this is a area under omega t curve results in angular displacement. Yes, clear this part? Chalo. And then we have also studied what is angular acceleration. So what is angular acceleration? So the angular acceleration is denoted by alpha. So which is again of two types. One is instantaneous, the other one is a average. So alpha average is nothing but omega final minus omega initial by t2 minus t1, or t final minus t initial. So which is delta omega by delta t, right? So and then alpha instantaneous is simply, so the d omega by dt. So units, what are the units? So radians per second square. Yes or no? So radian per second square. So from here you can also write, so we can write alpha is equals to d omega by dt. From here the d omega is equals to alpha dt. From here let's integrate it on either side. So the integration of d omega is equals to integration of alpha dt. So which is omega is equals to the integration of alpha dt. So which is nothing but the area under alpha t curve. So the angular acceleration time curve will result in the change in angular velocity, not angular velocity, it's a change in angular velocity. So the area under alpha t curve results in change in angular velocity. Clear? Understood guys this part? Chalo. So what is the direction of alpha, sir? The important question. So what is the direction of alpha now? What is the direction of alpha? See, the alpha is also a axial vector. So alpha is also a axial vector. So try to understand this thing properly. Alpha is also a axial vector, but its direction you cannot decide by the right hand thumb rule. The theta and omega, angular displacement and angular velocity, their direction can be decided by right hand thumb rule. So take the direction and curl your fingers, and then the thumb will give the direction of theta and omega. But what is the direction of alpha, sir? Angular acceleration. So it will be decided by the turning effect of force. What is the turning effect of force? The torque. Okay, so it will be along the direction of torque if the body is speeding up. So if it is speeding down, so it will be opposite to the direction of torque. So let me explain you. So it's an axial vector, but it's, see, if the body is rotating in this direction, so then you can say that the theta and omega are outward, axially outward. So theta and omega axially outwards. Okay. So but what about alpha, sir? Alpha, so it will support the torque if it is speeding up. Understanding? Alpha will be in the direction of omega. So if it is speeding up, the body is speeding up, so then alpha and omega, so they have the same direction. In this particular case, they both will be outwards. Okay, so same direction. But if the body is speeding down, so then alpha and omega will be in opposite directions. So just imagine, like, just compare it with velocity and acceleration. Compare with velocity and acceleration. So if the body is speeding up, so the velocity and acceleration will be in the same direction. So in the similar manner, so if the body is rotating faster, speeding up means rotating faster, so then alpha and omega will be in the same direction here. So if the body is speeding down, so what we say, velocity will be in one direction, so the acceleration will be in another direction, which we call it as retardation, right? So the same thing here also, if the body is speeding down, so in this case the omega is outward, so then alpha will be inwards. Alpha will be inwards. It will be along the axis, along the axial vector. That's for sure. It will be along the axis of rotation. That's fine. Alpha, theta and omega, they will be along the axis of rotation. There is no doubt about it. But theta and omega can be decided by the direction. Yes, how? So simply you can use the right hand thumb rule. If the body is rotating this way, so theta and omega will be this side. If the body is rotating this side, so theta and omega will be inwards. But alpha you cannot decide by the right hand thumb rule. So how do we decide, sir? So whether the body is speeding up, so the rotating body is speeding up, so then alpha will support the omega. Okay. So if the body is speeding down, alpha will oppose the omega. If omega is outward, alpha will be inward. Understood, guys? Clear? Chal. So this is about the angular terms. Hope we are clear with the angular terms. We already learned about this angular terms in circular motion itself. Just it's a revision kind of thing, because again we use these terms very frequently in this chapter. Okay, without these terms there will be no rotational motion. Clear? Am I clear? Chal. So this is clear. Chal. So the first question, so you guys can answer it easily. Read the question once. The direction of angular velocity vector is along the tangent to the circular path. See here, if the body is making the circular motion like this, this is the circular motion of the body. So let's suppose the body is moving this side. So then the direction of angular velocity is, see, if the body is moving, so the angular velocity will be along this direction. Yes or no? So what is this direction? This will be along the axis of rotation. So tangent to the circular path, so it no. So inwards radius towards this side, inward radius is nothing but the centripetal acceleration. What will be towards the inward radius? Towards the inward radius, that's acceleration is the centripetal acceleration, but they are asking about the angular velocity here. And the outward radius, centrifugal, no. So next, the axis of rotation, yes. So along the axis of rotation, so the angular velocity will be there, and theta also will be along the axis of rotation, and alpha is also along the axis of rotation, but it is supports omega, opposes omega, depends on the body's speed. Clear? Or torque. When you understand the torque topic, then you can understand the direction of alpha clearly, right? So let's take one more question, the simple question. So what's the question says? See, one more thing. So before solving this question, so here let me add one more slide. So we have seen what is omega. So omega is a angular velocity. Omega is a angular velocity. Yes or no? So this angular velocity has a direction, axial vector. This also we have seen. And then, so its units are radian per second. Radian per second. And then, so its relation with the time period and frequency. How do we write? So we know that omega is equals to 2 pi by t. So the relation of angular velocity with the time period. So omega by t. So where t is the time period. The time taken to complete one complete revolution is called the time period. Okay now. And we also know that the time period will be equals to 1 by frequency. Our frequency will be equals to 1 by time period. So frequency is 1 by time period. F is the frequency here. So now shall I write the omega in terms of frequency? Omega is equals to 2 pi by t. So which is nothing but in place of 1 by t I can write, so f. so which is 2 pi f. So therefore, so the angular velocity in terms of time period is 2 pi by t, and in terms of frequency is 2 pi f. So in the question frequency is given. How do we get to know if frequency is given or not? So if number of revolutions per minute, revolutions per minute or revolutions per second, if it is given, so that is said to be frequency. Okay. And then, so what is the number of revolutions formula? Number of revolutions formula, we have discussed about this in the circular motion. So the theta by 2 pi, angular displacement by the total displacement to complete the one complete revolution is a 2 pi. So theta by 2 pi is the number of revolutions that we get. Clear, guys? So this question done. So take this question. A wheel is rotating 900 rpm. What is this 900 rpm? So it's a frequency. So frequency is given 900 rpm. Next, so about its axis. So when the power is cut off, it comes to rest in 1 minute. So its time taken is 1 minute. Then, so the angular retardation in radian per second square. So the angular retardation means simply first find the angular acceleration. So then opposite of the angular acceleration is the angular retardation. Just keep the negative sign for the angular acceleration, then we'll get the angular retardation. So first let's find alpha. What is the alpha formula that we know? So omega final minus omega initial by omega final minus omega initial by T2 minus T1. Yes or no? So here first we know what is the omega initial. So when the power is cut off, it comes to rest in 1 minute. So its initial omega final is 0, alpha final is 0. So what is the initial? How do you find the initial omega? So omega is equals to, we know the frequency. So can I find the omega initial? So it is rotating initially. So 2 pi f, right? So 2 pi into, so what is f? So f is nothing but 900 revolutions per minute. So it is 900. So we need revolutions per second. So convert it to seconds. So here, so 1 15 times, 6 ones are 6 15 times, right? So 15 revolutions per second. So therefore it is going to be 15 revolutions per second. So which is nothing but 30 pi is the omega initial. Now can we find what is alpha? Can we find what is alpha? Alpha is equals to omega final. Omega final is 0 because it comes to rest. Omega final is 0 and omega initial is 30 pi by, so what is the time taken? 1 minute. So convert it to seconds. So that 60 seconds I am taking, right? So then alpha is equals to minus 30 pi by 60. So from here, so it's going to be alpha is equals to minus pi by 2 radian per second square. So this is angular acceleration. Now angular retardation will be pi by 2 plus pi by 2. So then I can write here. Then angular retardation. So the angular retardation is negative of the angular acceleration. Negative of the angular acceleration. Understood, guys? Clear? Everyone? Chalo. So let's take one more simple question. What's the question says? So what's the question says? See here. Angular acceleration alpha of the body is given. So alpha is given. So what is that? 4at cube minus 3bt square. These all questions you can do easily. So just pause the video and try it on your own. So if the angular velocity of the body is omega naught, initial angular velocity is omega naught. So then its velocity at time t will be, we need final angular velocity. See, alpha is given. They are asking the initial angular velocity. So we know that, so the omega is equals to, so the integration of alpha dt, omega is equals to the integration of alpha dt. That's it. So from here the change in omega, actually it is delta omega, or else we can write, so the d omega, let's write d omega from where to where? Omega naught to omega final. So now omega, and substitute here omega naught to omega final. So is equals to, so we can write, so what is this one? Alpha from where to where? So from where to where? 0 to t, right? After a time t will be. So it is starting, so 0 to t, right? So 0 to t. So what is the alpha value? They gave 4at cube plus, sorry, minus 3bt square. Simple thing, just do the integration part. So here it is omega final minus omega initial is equals to, so 4a t to the power 4 by 4, t to the power 4 by 4 minus 3b constant, take it out. So t square integration is t cube by 3, right? So from here 4 cancel, 3 cancel. So then we can write, so the omega final will be equals to omega final minus omega initial is equals to, so a t to the power 4 minus b t to the power 3. From here, so the omega final will be equals to a t to the power 4 minus b t to the power 3 plus omega naught. So plus omega naught. So this is the correct one. So omega naught plus a t to the power 4 minus b t to the power 3. Option A is the correct one. So here 4 a t to the power 4, no. Here 12, no. Here a t to the power 4 minus b t cube plus omega naught. So here these both options are given same. So just I guess something is missing in one of these. The option should be either A or 4. So we got the same answer, right? Yeah, omega naught plus a t to the power 4 minus b t to the power 3. So something is mistyped here, so wrongly typed. So we got the answer, however. So just mark either 1 or option 4, right? Clear. Chalo guys, let's go for the question number 4. What's the question says? The front wheel of an ancient bicycle has radius 0.5. So it moves with angular velocity given by the function angular velocity is given. So where t is in second, about how far does the bicycle move between the time t is equals to 0 to t is equals to 3 seconds. So they are saying how far the bicycle move. How far does the bicycle move? So what does they are, what they are asking? The linear displacement they are asking, or linear displacement or distance. Okay, what they gave? Angular velocity they gave. So first angular velocity function as a function of time it is given 2 plus 4t square. So let it be. So now shall I write? So first can we find what is the angular displacement? Can we find the what is angular displacement? So the theta, the d theta will be equals to the integration of d theta is equals to integration of omega dt, right? So from here, so the bicycle, so it moves with a velocity given by the function. So about how far t is equals to 0 its initial angular displacement is 0 and final angular displacement let it be theta. So the integration of d theta. So and then integration of omega, in place of omega we can write 2 plus 4t square. So into dt. From where to where? T is equals to 0 to 3 seconds. Yes. Now so here theta, the theta minus 0 is theta. So because the integration of d theta is theta, so the upper limit is theta and lower limit is 0. So theta minus 0 theta. So from here 2t plus 4t cube by 3. So from 0 to 3, from 0 to 3. So here theta is equals to, so now substitute the values. So if you substitute the upper limit 2 into 3 plus, so here I can write 4 into, so 3 cube, so which is 27 by 3. Yes or no? So lower limit if you substitute again it will come 0. 2 into 0 0, 4 into t cube means again 0, no need to substitute. So t is equals to here, so 3 ones are 3 nines are, so here it is 6 plus 36. So which is theta is equals to 42. So what is this 42? So this 42 is the angular displacement, so which is radians. But check the options, don't put the option as 42. If it is there 42 in the options, so don't put 42 because it's an angular displacement. So but what they are asking about how far does the bicycle move. So the linear displacement they are asking. So the linear displacement we know that S is equals to r theta. The relation between linear displacement and angular displacement is S is equals to r theta. So from here I can write S is equals to, what is r? the radius of the bicycle is given 0.5, so which is 1 by 2 I am writing. So the angular displacement I got 42. So 42 by 2, which is 21 meters, is a correct answer. So the correct option is option 3 is the correct one. Understood, guys? Clear the concept? Sure. Next, so let's move further. So now, what is the relation between V and omega? So V and omega, we know that V is equals to ds by dt. Yes or no? And then, so what is omega? Omega is equals to d theta by dt. Omega is equals to d theta by dt. So from here, you can write V is equals to d into, in place of s, shall we write r theta? In place of s, r theta. So everyone knows that the radius is a constant which comes out. So d theta by dt. So from here, so V is equals to r. What is d theta by dt? So d theta by dt is omega. So the relation between V and omega, so the linear velocity and the angular velocity, what's the relation between those two? V is equals to r omega. So right, V is equals to r omega is the relation between linear velocity and angular velocity, and S is equals to r theta is the relation between linear displacement and angular displacement. Linear displacement and angular displacement. Right? We have already studied these. You know that. Now, so let me tell you what is the vector relation between these two. So I am talking about, so the linear velocity and angular velocity, the velocity vectors relation I am talking about. So what's the relation? So it is V is equals to r cross omega. V is equals to r cross omega. Okay, so this is always valid, guys. So here this is always valid. Understood? So which we can write as r into omega into sin theta. Done? Chal. So let's take one simple question. So what's the question says? In a bicycle, the radius of the rear wheel is twice the radius of the front wheel. So let's suppose this is a rear wheel and this is a front wheel. So this is a bicycle. Okay, so let's suppose, so this is a bicycle. So some person is sitting here. Okay, so now, so they are saying radius of the front wheel in a bicycle the way. So the radius of the rear wheel is twice that of the radius of the front wheel. So let the radius of the front wheel be RF and radius of the rear wheel is RR. So here they said RR is 2 times the RF. Okay, so then, yeah. So if RF and RR are the radii and VF and VR are the speeds of the topmost points of the wheels. So the topmost points of the wheel has, so the rear wheel has the speed VR and the front wheel has the speed VF. So now what is the relation between, so the linear velocities of the rear wheel and front wheel? So here, without looking the options, you can, like without solving anything, you can just put the option. Tell me. See, the simple logic is, if the rear wheel moves with the velocity VR, so if the front wheel moves with the velocity VF, if their velocities are different, if their linear velocities are different, so this will move, let's suppose this is moving as it is having the radius more, so it moves faster, let's say, so it moves slower. So in that case, it should come and collide with this one. But is it happening while the bicycle moves? Will it happen? No, right? So that means they both have the same linear velocity. They both will have the same linear velocity. So then only the bicycle will move. Yes or no? Understanding, guys? So but their angular speeds will be different. Their angular speeds will be different. The number of rotations will be different. That's it. Clear? So which one will have the angular speed more, sir? So we know that the angular speed formula, omega is equals to, so theta by time. Yes or no? So omega is equals to theta by time. So or else you can write, so what is the relation between these? Omega is equals to V is equals to R omega. V is equals to R omega. So from here, so the omega is equals to V by R. So now the front wheel will have the omega, which is VI by VI, let it be, see here, the VR is equals to VF is equals to, let it be V. They both will have the same linear velocity. They both will have the same linear velocity V. So therefore the front wheel linear velocity is V by, so the front wheel's radius is what? RF. And then, so the rear wheel's angular velocity will be equals to, so its linear velocity is V by, so what is the rear wheel's this one velocity, linear velocity? VR. So or else RR we can write, radius, right? RR. So what is RR? So shall I write it as 2 times the RF, 2 times the radius of the front wheel. So now you can see that, so the omega of the front wheel is 2 times that of this one. Omega of the front wheel is 2 times that of the omega of the rear wheel. So this you can say, this is correct. But their linear velocities will be same, but their angular velocities will be different. Understood? Clear guys? So to confuse you guys, so they gave this question. So here they both should be same. So here all the options given same. So option wrongs, check any one option to. Here all the options they printed same, printing mistake here. So consider the option 2. Like any option you can take. So but change the options guys. Okay. So they gave all the options same here. By mistake they printed. Okay. Chalo. So understood a concept clear? So they have the linear velocity same, but their angular velocities will be different because their radii are different. Done? Chalo. So now, so let's suppose if a body is moving with the angular velocity, so the angular velocity vector will, see this is the circular path. So if the body is moving in this circular path, so then its angular velocity vector will be upwards. Let's suppose this is a circle. Let's suppose this is a circle. Here, this is a circle I am considering. So this is a circle, the same one. So the body is moving in this direction. So if the body is moving in this direction, so where the angular velocity is, angular velocity will be along the axis of rotation. This is the along the axis of rotation. So this is a omega direction, the direction of omega. This is the omega direction, right? So and here some radius will be there inside. So and then here the linear velocity will be there. So the linear velocity, let's consider at this point. This is the linear velocity V and this is the omega. Yes or no? So if you observe here, V is equals to, we know, R cross omega. V is equals to R cross omega. What is the angle between R and omega? See here, R is this one, omega is along the axis. Yes or no? If it is a circular motion, if it is a circular motion body, so then R is from center to this point on the circular path. So then, so what is the omega? Omega is along this side. So we can say that V is equals to, so magnitude of R into magnitude of omega into the angle between those two is 90 degrees. R is like this and omega is like this. So if the body is moving in this direction, omega will be downward. In that case also, if the omega is downward, so then also R will be perpendicular to the omega. Yes or no? So V is equals to R omega. So how this V will be? This V is also, what is this V? This V is perpendicular to the radius. This V is perpendicular to the radius, guys. Try to understand this concept. See here. So direction of, we know that V is equals to R omega. So here in this particular case, so the omega is along the axis. So as the body is rotating this side, if the body rotates this side, omega will be downward. So now omega is like this. This is a circular path. Omega is like this, and then the radius is like this. So the angle between R and omega is going to be 90 degrees here. Here it is going to be 90 degrees. So that's what I wrote, 90. So we got V is equals to R omega. So this linear velocity is again perpendicular to the radius. See here, this is the radius. This is the radius. So now on the circular path, at whatever the point you want the velocity, so just you have to draw the tangent there, right? So the radius and tangent are perpendicular to each other. Yes or no? So radius and tangent will be perpendicular to each other. So that V perpendicular is equals to R omega is the correct one. The V perpendicular is equals to R omega. Clear guys? R omega is equals to, so the V perpendicular by R. Otherwise you have to use this formula only. Understood? Clear? Chal. Done. So fifth question done. So this is done. So let's take one question so that you'll understand better. Find the angular velocity of B with respect to A. With respect to A. With respect to A means about this point. This will be the radius. This will be the radius. So now if you have to find, so the angular velocity omega is equals to what's the formula? V perpendicular by radius r. But this is the radius r is equals to 3 meter, about the point A they said. With respect to point A means about the point A. So r is equals to what? 3 meters. But so this, if it is the radius, we need the perpendicular velocity. But here the velocity is not perpendicular to the radius. This is the radius. So the velocity is like this. So the angle is here how much? 53 degrees. It's not perpendicular. So we need the perpendicular distance. How do we find the perpendicular distance to the radius? This is the radius. So the perpendicular distance will be like this. Yes or no? So if it is 20, this is 37. So then this is going to be 20 sine 37. Therefore, the V perpendicular is 20 sine 37. V perpendicular is going to be 20 sine 37. So I can write V perpendicular is 20 sine 37 degrees by, so the radius r, right? So now substitute the values. So 20 into what is sine 37? 3 by 5. Yes or no? By, so radius r is 3 again. So then I can cancel 5 ones are, 5 fours are, and then this 3 also will cancel. So the omega is 4 radian per second. So the omega is 4 radian per second is the correct answer. Clear guys? Option 4 is the correct one. So this V is equals to r omega is valid whenever the radius and velocity are perpendicular to each other. If the radius and velocity are not perpendicular to each other, so then you have to take the velocity perpendicular component. V perpendicular component you have to take. For which one? About the radius. For the radius, the velocity should be perpendicular. Understood? Clear? Hope the concepts are getting clear. Right? Chalo. So let's solve this question. Let's solve this question, guys. Chalo. So let's take one question here. So what's the question says? A racing car is traveling along a straight track, so at a constant velocity 40 meter per second. So this car is traveling at 40 meter per second. Yes, the car is very nice, orange color car. So what is that? Ambassador. A fixed TV camera, so here is a fixed TV camera, is recording the event as shown in the figure. Is recording the event as shown in the figure. That means car is moving. So it is a fixed TV camera. What it does? It, as the vehicle moves, it also moves. Like let's suppose it is fixed like this. So then vehicle is moving from here. So then what it does? As a vehicle moves, it also has to be moved. It also has to be moved. That means it is getting displaced by some theta. Angular displacement is occurring from here to here. Yes, you understood now. So in order to keep the car in view, so as the car moves, you have to track the car. Okay, so for that the camera has to be rotated. The camera has to be rotated. So in the position shown, so here to here the car is moving. So the camera is also rotating. The angular velocity of the car should be. So we have to find the angular velocity of the car. Okay. So let's suppose the car is already here. So now you should consider this is the radius, guys. The blunder most of the students does is, so they consider this 30 meters is the radius. No, the car is moving. At that instant we have to find. So at that instant, at the instant where, so the car is already moving, it has already moved to this point. So from this point you should consider the radius. Understanding? So what is the angular velocity formula? You know that V is equals to, the omega is equals to V perpendicular by R. V perpendicular by R. So but here the velocity and radius, they should be perpendicular. So this is the radius. This is the radius. First we don't know what is the radius component. That's the first thing. And then, so then we need the velocity. Velocity is this side, radius is this, and velocity is this. So they both are not perpendicular to each other. So what we have to do in this situation? So the radius and the velocity perpendicular means this, the perpendicular component will be this one. the perpendicular component will be this one, the velocity perpendicular. So if you know this and this, then you can directly substitute it in the formula. This is the r, this is the r, and this is the v perpendicular. Clear, guys? For that we should know what is this angle, and then what is this r. R you can easily find. R how can you find? So this triangle, it's already 90 degrees here. Yes, sorry. So this is already 90 degrees here. So from this triangle, let me take, so this is the adjacent, this is the hypotenuse. So let's take cos 30. Cos 30 degrees is equals to, cos 30 degrees is equals to, so I can write adjacent is 30 meters by hypotenuse is r. From here, r is equals to, yes or no, adjacent by hypotenuse. So adjacent, r is equals to 30 by cos 30. So let it be. R value we got. Now the next thing is, we need to know what is v perpendicular. So the v is 40 meter per second. It's not perpendicular to the radius. It's not perpendicular to the radius. The perpendicular component is this one. We need this. So for that, what I am doing is, let's draw a simple parallel line here. So for this, I am drawing a parallel line. So if it is 30 degrees, so this is also going to be 30 degrees. If it is 30 degrees, this is also going to be 30 degrees. So then, as this one and this one are perpendicular, this total angle is 90. So this should be 60 degrees. Yes or no? So if it is 60, and again this angle should be 30 degrees. Why this is 30? Because this is 60 and this should be 30 degrees. So from here, so I know this is 30. So the v perpendicular will be 40 cos 30. This side we get 40 cos 30 degrees. 40 cos 30. So I got the v perpendicular also. So now let's substitute the values. So the omega is equals to, what is v perpendicular? So the v perpendicular from here, it is 40 cos 30. 40 cos 30. So just substitute 40 cos 30 is the v perpendicular by the radius r. R is what? 30 by cos 30. 30 by cos 30. Yes, yes. So now omega is equals to, we can write, so 40 by 30 into cos 30 cos square 30. Yes or no? So from here, so 3 cancel, so 0 cancel. Omega is equals to 4 by 3 into, so what is this cos 30 value? So we know that cos 30 is root 3 by 2. So root 3 by 2 whole square. From here, so square root of 4 by 3, square root of 3 is this, root 3 whole square is 3. 2 square is 4. So 3 cancel, 4 cancel. The omega is equals to 1 radian per second. 1 radian per second. Option 4 is the correct one. Most of the students take this as the radius. R is 30, and then so the perpendicular velocity is 40. R 30 into 40. So you do like that. Sorry, 30, not 30 into 40. V is equals to, so 40 by 30 you do. Most of the students, they do like that. So but at that instant, this is already the radius, and then from there you should consider the perpendicular velocity. So the same question you can also frame it in variables. So the same question can also be asked, and it was asked in the JEE previously. Okay, so in terms of variables also, let's do the same thing. Let's do in terms of the variables. So this is, the vehicle is moving from here to here. So let's consider this is the distance x, this angle is theta, this is the radius r, and consider this will be, the car is moving with a velocity v this side. So the car is moving with a velocity v this side. So now we need the v perpendicular. This will be the v perpendicular, right? So now see here, the first thing is, so the first thing is, so if it is theta, so then let's find r now. So I can write cos theta is equals to adjacent by hypotenuse. From here we need r. R is equals to x by cos theta. This is the first equation. Let it be. So then if it is theta, so this will be theta. So this will be 90 minus theta. Yes or no? So this will be theta again, because if it is theta, this is theta, alternate angles. So then this will be 90 minus theta. So if it is 90 minus theta, this will be theta again. Now, so can we find what is v perpendicular? V perpendicular is v cos theta. Yes or no? Theta is this side, so v is here. So that this component will become what? So V cos theta, V perpendicular. So we have got V perpendicular is equals to V cos theta. So from here, what do we need? So we need omega. Omega is what? V perpendicular by R. Yes or no? V perpendicular by R. So what is V perpendicular? V cos theta by what is R? R is X by cos theta. So from here we get V by X into so cos theta whole square. So which is nothing but cos square theta. So they might also say that so the omega is directly proportional to cos square theta, right? So we can say that also. They can frame question based on this also, which was framed also previously in JEE. So let's suppose, just imagine if a person is just passing by you, just passing from passing in front of you. So he has moved from here to here. So then you have to, if you have to observe him, so you have to observe like this. Yes or no? So suddenly your angular velocity changes. Yes or no? From here to here. First person is here first, then he is here. So then here to here. Suddenly your angular velocity changes. Yes or no? So then, whereas if you are observing the very far point, let's suppose you are moving in the train. Okay. So you are observing a tree or something. Okay. So then, so while the train moves, the trees which is very far, you are able to see it while the train moves, right? So now also you are seeing, now also you are seeing, now also you are seeing, now also you are seeing. So that means the omega decreases with theta increases. The omega decreases with theta increases because as the cos 0 to cos 90 decreases, right? Cos 0 is 1, cos 90 is 1, cos 90 is 0. So as theta increases, so the cos theta value decreases, yes or no? And omega value also decreases. So that's why, so for the, if you are observing the far points, so you need not to rotate your head suddenly. So just you can move like this. Yes or no? So but just passing very shorter objects. So if it has moved from here to here, so then your angular velocity changes like this. Yes or no? Understanding? Clear? So this is a concept, guys. So the question and its concept. So we don't need another slide here. So let's delete this one. So now the rotation with constant angular velocity. So in the question they mentioned that, in the heading they mentioned that, so the omega is constant. So if omega is constant, the first thing is alpha is 0. What is alpha? Alpha is equals to d omega by dt. So which is nothing but 0. So we have got what is alpha. And then, so then what is the tangential acceleration? We know the tangential acceleration is equals to d into the magnitude of velocity by dt. D into the magnitude of velocity by dt. So now in place of this I can write, so d into, so in place of v, shall we write r omega? V r omega by dt. So here r is constant, radius is constant, and as per the given statement omega is also constant. So they both are constant. So the differentiation of constant terms will be 0. So that means there will be no tangential acceleration. So this term is also done. Tangential acceleration done, alpha done. So now what will be the centripetal acceleration? The centripetal acceleration will always be there. It will be along the radius. So what is the centripetal acceleration AC? Either you can write v square by r, or r omega square, or v omega. So the AC part is also done. So now let's write what is A net. So how do you write A net? So if the body is moving in a circular path like this, so the centripetal acceleration will be towards the center of the body. So this is the centripetal acceleration AC. And then, so the tangential acceleration will be along the tangent AT like this, guys. Yes or no? So now the net acceleration of the body will be, so the resultant of these two, AC and AT, their resultant will be the net acceleration. So I can write, so the A net will be equals to, so square root of the centripetal acceleration square plus the tangential acceleration square. That's it. Yes. So from here, so the A net is equals to, I can write AC square plus AT square. You learnt all these things in the circular motion itself, guys. Clear? Chal. So A net is equals to, so AT is however 0 in this case because omega is constant. So what is AC? In place of AC you can write any of these things, your wish. So let me write R omega square, so which is nothing but omega times R, or else you can write any other. So we can simply say that the A net will be equals to AC in this particular case. So that AC can be AV square by R can be R omega square, R can be V omega, so it can be anything. Sorry, because square and root cancels, right? So here A net will be equals to simply AC only, which is equals to either V square by R or R omega square or V omega. So this is when the rotation with constant angular velocity, if the omega is constant. So what about all these terms? So that we derived. So now what if omega is not constant? So rotation with angular velocity which is varying, the variable angular velocity. So then omega is a variable. If omega is variable, so then we can write alpha will be equals to d omega by dt. Alpha is equals to d omega by dt. So what is omega? You can write omega in place of omega. So you can write r theta. V is equals to r omega. Sorry, no need. So just write this one. So alpha is equals to d omega by dt. So yes or no? So then alpha we got. So then what is at? The tangential acceleration at will be equals to d. So v by dt. So in place of d, v, we can write r omega by dt. So now r is constant, v is omega is variable. R is constant, omega is variable. So I can write d omega by dt. So what is d omega by dt? Just now we wrote alpha. So therefore the tangential acceleration is equals to r alpha in this particular case. So we have got what is tangential acceleration. This is alpha when omega is variable, and then so this is the tangential acceleration when omega is variable. If omega is not varying, there will be no tangential acceleration, guys. Remember that if the omega is not varying, so the tangential acceleration will be 0. Previous case, if the omega is varying, the tangential acceleration will be equals to r alpha. Done? Yes, fine. So now, so we have got this term and we have got AT. And AC, however, it's going to be same, either r omega square or v square by r or v omega, right? So and then, so what is A net? So AC is also done. So what is A net? So the, if the body is moving in circular path like this, so the AC will be towards the center and AT will be along the tangent. Yes. So then the A net will be the resultant of these two. So the A net is equals to square root of AC square plus AT square. AC square plus AT square. Done. So you can substitute any of these values. Either you can write r omega square, r alpha whole square, your wish. So you can substitute any formulas. Okay, clear guys? Done. Chalo, next. So this is with omega varying and omega constant. So let's take one simple question. So the question number 8. So what's the question says? So what's the question says here? The angular velocity of a particle moving in a circle of radius 1 meter varies with the time. Omega is equals to 2t. Angular velocity varying with the time. Omega is equals to 2t, guys. So fine. So radius is also given. So the radius is 1 meter. Fine. So find the radial acceleration. The radial acceleration means acceleration which is along the radius. So what will be the acceleration along the radius? Which is a centripetal acceleration. So the first thing is AC they are asking. So and then what is the tangential acceleration? So we can find tangential acceleration also. And what is the net acceleration? See, first let's find the tangential acceleration. So at t is equals to 2 seconds we required. So first let's find. So AT is equals to r alpha. AT is equals to r alpha. So what is alpha? First find alpha then. Alpha is equals to d omega by dt. Alpha is equals to d omega by dt, right? So d by dt of what is omega? Omega is 2t. So 2 is a constant, dt by dt is 1. So alpha is equals to 2 radian per second. So we got alpha, fine. So then what else is required? Radial. So radial, let's find later. So first find AT. So AT is equals to R alpha. What is R? 1 meter. So what is alpha? 2. So which is nothing but 2 radian per second square is the tangential acceleration. So we have got this. Next. So then let's find what is AC. So AC is equals to, so either we can use V square by R. We don't know what is V. And we can use R omega square. So R omega square. At t is equals to 2 seconds we have to find. First find omega which is at 2 is equals to 2 seconds. So how do you find omega at 2 is equals to 2, t is equals to 2 seconds means in place of t you substitute 2. Omega at t is equals to 2 seconds will be 2 into 2, 4. Then AC will be equals to, let me use the formula, R omega square. What is radius? 1 meter. Omega square is 4 whole square. Yes or no? Omega at 2 seconds is 4. So we have got the AC, the centripetal acceleration is 16 radian per second square. Yes or no? Understood guys? So we have got the radial acceleration. Where is that? This one. And tangential acceleration, this one. And then net acceleration, angular acceleration we already got. This is alpha is angular acceleration. So then what will be the net acceleration? So you can find it easily. So the A net will be equals to square root of AC square plus AT square. Yes, so do the simple calculations. What do we have? So AT square, AC square is 16 square, AT square is 2 square. So which is nothing but, so how much it will be? 256 plus 4. Yes or no? 225, 256 plus 4. So root 260. That's it. Understood? Clear guys? So this is a concept. Done? Chalo. So let's move further. Yes, done. Next. So then motion with uniform angular acceleration. So that means uniform angular acceleration, if alpha is constant, so then what are the formulas that we can write? So if acceleration is constant, uniform acceleration in the kinematics linear terms we have studied. So where V is equals to U plus AT, S is equals to UT plus half AT square, and V square minus U square is equals to 2AS. V square minus U square is equals to 2AS. So and then we have also studied, so the distance covered in the nth second will be equals to U plus A by 2 into 2n minus 1. So this also we have studied. And then so the displacement is equals to U plus V by 2 into the time taken t, U plus V by 2 into time taken t. So the same formulas you can adapt to the motion with uniform angular acceleration. So the terms will be changed to the angular terms. So how guys? So here final velocity V, in place of that you can write final angular velocity omega f. So initial velocity here U, here it is initial angular velocity omega I, and angular acceleration alpha, time t, theta angular displacement, yes linear displacement. So just change these terms. So omega f is equals to, I can write here. So the first one, omega f is equals to omega I plus, in place of A, alpha into t. And the second one, S is nothing but theta is equals to omega initial into time t plus half A means alpha t square. So V square omega f square minus omega I square is equals to 2 alpha theta, right? So and then you can also write the distance covered in the nth second. So this is S is equals to UT plus half, sorry, not this one. So this one. So the distance covered is equals to S is equals to U plus A by 2 into 2n minus 1, right? So in place of omega, so U we got omega I, and A alpha n and then theta S. Clear? So this is the distance covered in the nth second. Actually this is the angular displacement in the nth second. Done. Clear guys? These are the formulas which you already know. So let's take one simple question again. So what's the question says? See, whenever the question appears, let's try to do it on your own guys. Okay. So just try this question on your own. A wheel has an angular acceleration alpha is given. So 3 radian per second square. And an initial angular speed of omega naught is given. Initial angular speed, so which is 2 radian per second. So then in a time 2 seconds, t is equals to 2 seconds. So it has rotated through an angle theta. So they are asking, so what is the angle theta in radians? So first to find angle theta, so what do we require? So theta is equals to omega naught t plus half alpha t square. So we have got everything, I guess. Omega naught 2 into time 2 plus half alpha 3 into t square. So what is t? 2. So 2 square is 4. So here it is 4 and 2 6. So which is 10. So theta is equals to 10 radians. So the correct option is option. So the option 10. 10 radians means option 1. Clear? Chal. Next. So let's take the next question, guys. A uniform circular disc 50 centimeters which is at rest is free to turn about an axis which is perpendicular to its plane and passes through its center and is subjected to a torque which produces a constant angular acceleration alpha is equals to 2 radian per second square. Its net acceleration in meter per second square at the end of 2 seconds approximately. So here alpha is given, what is that? 2 radian per second square, and radius is given, what is r? 50 centimeters. So then which is at rest? So the initial angular velocity is 0 about a point perpendicular to its plane, so passes through its center. It's subjected to a torque which produces a constant acceleration, and time is also given, which is 2 seconds. So then we have to find what is the a net, the net acceleration. What is the a net? So a net means we need AC and AT. We need AC and AT. So first let's find AT, or AT is nothing but r alpha. The tangential acceleration you can easily find. So AT is equals to r alpha. So what is r here? R is 50 centimeters converted to meters. So 50 by 100 into, so alpha 2. So here 0 0 cancel. So 2 2. So AT is equals to 1 radian per second square. Right? So we need it in meter per second square only, na? Okay, so let it be. So A is equals to, so the AT is equals to, we have got, so this is 5 2 1, fine, let it be. So then next, so let's find what is the AC. So to find AC, we have got formula either V square by R or R omega square or V omega. So we don't know what is V, so let's ignore this formula and this formula. So can we find final omega? How do you find the final omega? So let's use this equation. So omega naught plus alpha t. So from here, so the final omega will be equals to omega naught initially is 0 and alpha is what? Alpha is 2 into time is 2. So this is going to be 4. So we have got omega final is 4. So then what will be AC? AC is equals to r omega square. R omega square. R is what? 50 by 100 into omega square, which is 4 square. Yes or no? So omega is 4, right? 4 square. So here 1 by 2. So this is 16 by 2, which is 8. So AC is 8 and AT is 1. So from here, let's write what is the A net. So the A net is equals to square root of AC square plus AT square. So which is nothing but, so square root of AC 8 square plus AT 1 square. So which we have got, so 64 plus 1, so root 65, so approximately 8. So we can take approximately, the answer has to be 8. Yes or no? So they asked what is the net acceleration only, right? So they asked its net acceleration at the end of 2 seconds is approximately, at the end of 2 seconds. First we calculated what is AT. So AT is nothing but R alpha. R we know and then alpha we know. So just we substituted, so that we got AT is equals to So 5 2 times. So here 5 ones are 5 2 times. So 2 into 2. So 2 and 2 1 here we get. And then AC also we calculated R omega square. What is omega? So omega naught plus alpha t. Alpha is 2, t is 2. So 2 into 2 4. So omega f we got. R is, so again 1 by 2 this one. So 1 by 2 into 16, which is 8. So we have got approximately 8 is the correct answer. 8.1. So you can take approximately 8. Clear? Understood, guys? Sure. So let's talk about the next topic, that is torque. Let's discuss about the torque now. See, the torque is nothing but it's a turning effect of the force. It's a turning effect of force. The torque is the turning effect of the force. Clearly. Okay. So that means about a point, how much force you should apply to rotate it. That's called the turning effect of the force. This body is there. If you have to move it, so you have to apply how much force. Okay na? So in the linear terms, whatever the force plays the role, in the angular terms, the torque plays the same role to rotate it. Let's suppose if you are tightening the screw or losing it. So then what you do? So how much force? That force is a torque. So to rotate it, how much force you are applying? So about that point. So that's a torque. Understand, guys? The rotational force is nothing but the torque. Okay. So now can we just do the analogy between the linear terms and angular terms? See here. So let's write. So the linear term here and then the angular term here. So just to have the idea. And then let's write the relation between them also. So I can write the first thing. So the linear displacement S, angular displacement theta. So the S is equals to R theta is the relation between those two. And then linear velocity V, angular velocity omega. So the relation between them is V is equals to R omega. And then so linear acceleration A, angular acceleration alpha. So then AT is equals to R alpha. And similarly, in the linear case, so we have force F, and then in the angular case we have the torque. So they both are related by the torque is equals to R cross F. We are going to see this formula. So just to have the idea, I am writing. So and then, so in the linear terms, whatever the role that the mass plays. So here in the angular terms, the moment of inertia, I is called the moment of inertia. So where, so the moment of inertia will be equals to mr square. So here I is called the moment of inertia. I is a moment of inertia. Clear, guys? Understanding? Just this analogy you should remember between the linear terms and angular terms so that you can solve the questions very, very easily. Done, guys? Chalo. So let's talk about the torque now. So the torque formula is either force into the perpendicular distance or the perpendicular force into the distance. Let me explain you this concept. So the torque is equals to, here I wrote the force into the perpendicular distance. Force into the perpendicular distance. So let me give you an example. Let's suppose, so here this is a nut. This is a nut. So now you are applying to tighten this or loosen this, you are applying the force in this direction. You are applying the force in this direction. So now see here. So this is a perpendicular distance to the force. This is a perpendicular. Here force you are applying here into the perpendicular distance. So about this point you are applying the force. Yes or no? If you apply the force like this, so then what happens? It will be, the torque will be applied. So where the torque is applying, sir, the torque is applying, this is a, about this point the torque is getting applied. Okay, so this is a perpendicular distance. So we can write the torque in this particular case is equals to force into the perpendicular distance. So here the force is applying into the perpendicular distance. Understanding? Or else you can also write, let's suppose this is a body. This is a body. So then if you are applying the force this way, at an angle theta, at an angle theta. So now if you are applying the force this way, what will be the perpendicular component of the distance? So about this point you are rotating this one. Consider about this point you are rotating this. So about this point. So this will be the perpendicular distance. So this should be the, let's suppose this is the distance r. So then if this is a force F, if this is a force F, so then what will be this component? What will be this component? This will be the perpendicular component, the perpendicular distance. So the torque is equals to force into the perpendicular distance. See, the force into its perpendicular distance. Understood? So this is the first formula for the torque. So everything will be cleared. Just listen carefully. Okay. So every doubt you are having, so it will be cleared. Okay. So and next, one more important point. If the applied force is parallel to the radius r, if applied force, if the applied force is parallel to, if the applied force is parallel to the r, then torque will be 0. Then torque will be 0. So let me tell you the example here. So here is a point. About this point you have to apply the torque. So then you are applying the force along this direction. So this from here to here, it is the radius or the distance r. So see here, your force component is along the radius, along the distance r. So if the force is along the r, so then in this particular case, so the this one will become 0, because it's r perpendicular is 0 right here. There is no perpendicular distance for the r. So if you take the force perpendicular radius distance perpendicular distance, so there is no perpendicular distance for that, only this distance is there. Understanding, guys? So F into r perpendicular, so that r perpendicular is 0, so torque will be 0 in this particular case. Okay, so this is the first important point. And so the next important point, so if applied force passes through axis of rotation, then torque produced by that force will be 0. Torque produced by that force will be 0, guys. So let me explain you this concept. See here. So this is a object. So you want to rotate this one. So about this point you want to rotate. So now you are applying the different forces. So what are the forces? So here you are applying one force, and here you are applying one more force. Let's suppose this is F2, this is F1, and consider, let's suppose you are applying some F3 force, and you are applying some F4 force. Now tell me, so the torque will be produced due to which forces, and torque will not be produced due to which forces? Tell me, guys. The first thing, understand it in the simple words. So the two concepts, if the force is parallel to the distance r, here this is the distance from here to here, yes or no? So here F2 is parallel to the r, the torque due to F2 will be 0, because it is along the distance only, it is along the distance. And then, so consider the F4, guys, consider the F4. So the F4 is passing through the axis of rotation. This is the axis of rotation. So therefore the torque due to F4 is also 0. Understood now the concept? So if a vector, the force vector is passing through the axis of rotation r, if the force vector is parallel to the r, the distance, so then the torque produced by such forces will be 0. Yes, clear? I'll take one more example. See here, let me take this one. So consider, so this is the ground, and then I am placing an object here. So this is a object of mass m. So let's suppose, so this object, the force F is here, and on this the normal N is acting. So let's suppose, so I am applying the on this body I am applying the applied force F. So and then its weight mg is acting downwards. So now you tell me, so the torque due to which force will be 0? The torque due to friction force will not be 0. It is not passing through the. So and then the torque due to normal is not 0, but the torque due to force will be 0. The torque due to F will be 0 and mg will be from the center, right? So the torque due to mg will be 0. Understood, guys? Clear? So two things that you have to remember. One is, if the applied force passes through the axis of rotation, then torque by that force will be 0. And then if it is parallel, if the force is parallel to the distance, so then the torque due to that applied force will be 0. Clear? And then, so you can also write, so what is the direction of torque? So how do you find the direction of torque? So see here. So the torque is equals to R cross F. We write the formula R cross F. So you know the direction, right? What is R cross F? So the direction R, from R to F, you curl your fingers and your thumb will give you the direction. So you know the cross product. This is a cross product. How do you find the direction in the case of cross product? See, let's suppose if C is a vector which is the resultant of A cross B. So then curl your fingers from A to B. Let's suppose this is a vector, this is a B vector. So then curl your fingers from A to B. Curl your fingers from A to B. So the thumb will give you the direction of C vector, the resultant. Right? And similarly here also. So the R cross F, so will give the direction of the torque. Understood? So from R to F, you curl your fingers and your thumb will give you the direction of torque, right? And then, so one more thing, in the cross product we have studied that, so the resultant, the C, it will be perpendicular to vector A and it will be perpendicular to vector B as well. So the resultant of cross product of two vectors will be perpendicular to two individual vectors. Individual vectors, C is perpendicular to A and C is perpendicular to B. In the similar manner, here also the torque will be perpendicular to R and the torque will be perpendicular to F. So the torque will be perpendicular to R and the torque will be perpendicular to F as well. Okay. So now see here, now I can write, so if two vectors are perpendicular, their dot product will be 0. So the torque dot R will be 0 and then torque dot F will be 0. Understanding, guys? First, what is torque? Right? So torque is either force into the perpendicular distance, or the perpendicular distance, or the distance into perpendicular force, whatever you can take, your wish. So next, the torque direction you can find it by R cross F. So the torque direction you can calculate it by R cross F. So then torque will be perpendicular to R and torque will be perpendicular to force. So torque dot R will be 0, torque dot F also will be 0. So torque, it is tau. We actually pronounce it as tau. Okay, so let's take this simple question, guys. What's the question says here? So what's the question says? If F is a force acting on a particle having position vector R and tau be the torque. So position vector is R and tau is the torque of this force about the origin. So then you know that, so tau, R dot tau is 0, F dot tau is 0. So this is the correct one, just now we have seen, right? So the tau is equals to R cross F. Yes. So then tau is perpendicular to R and tau is perpendicular to F as well. So we can say that the tau dot R is 0 or R dot tau is 0. So that's what they first wrote, R dot tau is 0. So because the dot product is commutative, R dot F or F dot R, both are same. So the second one here also you can write F dot tau is equals to 0. Clear, guys? So the first option is the correct one. Let's take the next one. So what's the question says? A simple pendulum of length L is pulled aside to make an angle theta with the vertical. So let's suppose initially the simple pendulum is like this. So it is having some mass m. so having length L. So now it is pulled aside to make some angle theta. So it is pulled aside to make some angle theta. So this side it's making some angle theta, guys. Fine. So then find the magnitude of the torque of the weight of the bob. So what will be the weight of the bob, guys? So this will be the weight of the weight of the bob. So this is the mg here. So this is also the mg. Now, so here the thing is, so two things. So this is the weight. We need the torque due to this weight. So the torque due to this weight. So we need the force into perpendicular distance. How do we find the perpendicular distance? Force into perpendicular distance. So first thing, if you extend this, just to understand the basic concepts. So here, if this angle is theta, so this will be also the angle theta. Yes or no? And then, so this will have mg cos theta, the weight component, and this side we get mg sin theta. So now, so this will be the perpendicular component. Yes or no? So the distance, so the torque is equals to, so the force into, or else R into the perpendicular component of force. Yes or no? What is R? Here this is the R, which is length L, into what is the perpendicular component of force, which is mg sin theta. So simply the torque due to this will be mgl sin theta. mgl sin theta. Clear, guys? Or else if you need, you can do this also. See, so this is the method 1. Or else, so you can find it by the other method also. What is that method? So see, this is a mg. So you can find what is this distance. You can find what is this distance. This side, this total length will be L. So this side L sin theta, L cos theta will come. This side L sin theta will come, because this angle is theta. If it is theta, this also will be theta. So then this side L cos theta and this side L sin theta will come. So L sin theta this side and mg this side. Not understanding. See here. The same thing you can do this way also, right? So if it is a mass m, so if it move to this point, so this is a m. So let the force be like that only. Now I am writing the new formula for the torque. So that is torque is equals to force into, let's write the perpendicular distance. Force into perpendicular distance. Previously we have seen, what is that formula previously? So the torque is equals to R into perpendicular distance. R we kept it like that, and perpendicular distance of the force is mg sin theta. So now what I am doing is, so in the method 2, so you can use this formula also. What is that? Let the force be like that, let the mg be like that, and for that what is the perpendicular distance? So for that the perpendicular distance will be this one. So if it is the length L, if it is the angle theta, so then, so this also angle theta. So this side, if it is the length L, so this side component will be L cos theta and this side component will be L sin theta. So mg is the force, this is a force, and this is the L sin theta is a perpendicular distance. L sin theta is a perpendicular distance, guys, right? So from here the torque will be equals to, force is what? Mg. Due to which force you are finding the torque? Due to its weight, bob weight. So the bob weight is mg, that's a force. So now what is the perpendicular distance for that? This one. So L sin theta. So same thing you get, either force into R into the perpendicular force, R into, let the string be like that, and find the perpendicular component of the force. Mg perpendicular component is this one. Yes. Or else let mg be like that and find the perpendicular distance of L sin theta. In both the cases you get the same answer. Clear? Chalo. So this a small ball of mass 1 kg is attached to one end of a 1 meter long. So the string length is given and other end of the string is hung from a point. So when the resulting pendulum is making 30 degrees with the vertical, so what is the magnitude of the torque? So just a previous question substitution. So let's take this as homework 1. Just in the torque is equals to mgl sin theta, the same previous question, but this time values are given. Mass you know, L you know, G value you know, and then theta value also they gave. Nothing there, you have to just substitute and put the answer. So do that. So next, so the next question, 14th one, NEET 2020, it's given. So find the torque about the origin when a force is given, force vector is given. So 3j cap newtons, and acts on a particle whose position vector is given, r is also given, so 2 k cap. So then the torque will be equals to what? R cross F, right? So what is R cross F? R is 2 k cap cross, so 3 j cap. So 2 into 3, 6. So here what is k cross j? So you know this, right? So the shortcut I, j, k. So what do we require? So we need k cross j. So that means anti-clockwise. So anti-clockwise negative. So k cross j will give minus I. If it is clockwise, positive you take. Clockwise means I cross j will give k, j cross k will give I, k cross I will give j. But anti-clockwise, I cross k will give minus j. So k cross j will give minus I. So here minus I. So minus 6 I cap. So minus 6, see 6 I is there, minus 6 I is there. So minus 6 is the correct answer. Minus 6 I Newton meter. Clear guys? Understood? So the moment of force is given about the point, and so this is the force acting, and about the point 2 comma minus 2 comma 2, so is given by, see here the same thing, you have to find the position vector of these two, and force vector already given. So the torque is equals to simply R cross F. So just you have to find the position vector of these two. So first to find the R vector, the position vector, how do you find? So which is final minus initial, R2 minus R1 you find, R2 minus R1 you find, and then so substitute here R vector you get, force vector you get. So let's take this as a homework too. So simple questions. So this question asked in NEET 2018. Done. Understood guys? Yes. So that's it from my end. So this is the first lecture of your rotational motion. So just we introduced what is torque and how the torque is applied. So and in the next class we'll see, so the torque due to the torque, the net torque on the body, if the different forces are acting at the different points, so what is the net torque about the given point, okay? And we'll also see the static equilibrium and rotational equilibrium concept, okay? So till then, keep studying. All the very best. Bye. Thank you guys.